Hi, my name is Keith and welcome to another PolyWorks webinar video. Today, I want to go through a basic inspection workflow, but an updated version to the new 2024 ribbon. We'll write a program offline, and then we'll also add on the extra ability to upload the data to Data Loop. So then afterwards, our guys on the shop floor can quickly start inspecting parts with a real device on real parts. So obviously, this is the PolyWorks 2024 Workspace Manager. I'm just going to double check that I'm actually logged in to our AWS Data Loop server. I'm going to start by creating a brand new workspace, and we're actually going to create a program to measure a steering knuckle. Okay, and then I'll start a brand new inspection program. And what you'll see now is, if you're familiar with PolyWorks, then obviously this will be quite different to how you've seen PolyWorks in the past. If you're new to PolyWorks, welcome, and this is the new interface. We have now our kind of new ribbon style layout, similar to what you may already been experiencing with the Microsoft suite of applications. See Microsoft Word, Excel, and so forth. We're all laid out in a similar fashion where you have ribbons along the top. In this case, we have a File tab, giving us access to the ability to start brand new workspaces or programs, open, save, upload, options, so forth. We have the main Home tab with majority of our basic measurements that we're interested in creating, as well as importing and exporting. We have a Device tab to be able to connect to our devices, our Measurement tab to commence measuring or writing a sequence. We have the ability to generate alignments, our Review tab. Once we've done the inspection, we can then start to actually create report items using the Review tab. Any kind of display settings, options, what you used to see down the kind of right-hand side of PolyWorks has now been placed under the View tab. Macro scripts is becoming more and more of a used functionality in PolyWorks, and now there is a specific ribbon even for our macros. And then any additional toolbars, whether it's ones that are available to download from the PolyWorks, My PolyWorks portal, where there are some kind of pre-made macros you can download, or if you have any of your own, you can add in your own ribbons or tabs within the ribbon. So all this is customizable as well. To import your CAD in, it's just a matter of jumping into the big obvious import button now. And you can see there we have the ability to import CAD model. Because when connected to Data Loop, there are also abilities to connect to PLM systems, so I can download CAD models from the likes of Windchill or Teamcenter, but I don't have that here, so I'm going to browse locally. PolyWorks, through data, and I have a steering knuckle CAD model I want to bring in. So that process remains pretty much the same, but now there's just a nice big import button for you to use. Next up, let's go and start creating our datums like we normally would. I can create features. So features are now kind of laid out for you. So you've got direct access to the create features tools. But there's a nice big button here which allows you to automatically create features by picking on the CAD model to generate automatic features. Or automatically detect. So here I can tell PolyWorks that I wish to create datum A. Datum A will be the cylinder on the inside here. So if I zoom in, datum A, I can choose datum B as that face. Datum C will be the circle top here. And then the rest can be just standard features. So I'll go circle 1, 2, we'll make this one another datum, followed by circle 3. We'll create another cylinder on the inside here. And we have our plane on the other end. Again, I can go through, create any additional items I need from there, but that's how simple it is to create features. If you want to create anything more specific, what I want to create an average between two planes, you can see there I can go straight to my create plane feature and again choose the method of how I wish to create features. So a lot of that has remained the same. It may look slightly different, but it's now laid out. It's laid out slightly differently, but the basic tool itself is the same as always. One handy functionality in 2024, though, is the ability to actually highlight multiple items in your tree. And rather than going to tell PolyWorks I wish to create planes specifically, I can actually right-click on them and actually create features such as planes from those two planes. And it will automatically change the method to an alternative method of either from objects, from intersection, based upon what type of features you've selected. So in this case, you can see automatically it's gone to from objects and then average of planes. So it's quite easy for me to create that plane there between those two. While I'm here, let's go ahead and quickly create some dimensional information. So I wish to create some distances between, say, for example, circle 1, circle 2. I'll go from the larger circle datum and so forth. So those I can just lay out quite quickly, nice and easily. I may even want to do a distance, for example, between this plane and that plane to get an overall length, and maybe even the distance between the two inner cylinders. Nice and straightforward. So again, none of that has really changed much. It's just where the location of the tool is. Same with our next set of tools. I want to measure some comparison points across our part. So I'm going to create some comparison points. Again, the creation method all remains the same. It's just where the location of the button is. So now I can go ahead and start anchoring some comparison points. I'll dot these just randomly across the part. Nice spread of points there. Maybe even create some cross sections. So I'll create cross section, maybe just one down the center of the part, which means when I view it, I'll view it in the Z orientation. So let's tick the Z axis at 0, preview that. You can see that straight down the middle. If that wasn't down the middle, then obviously I can always anchor point and pick roughly where I want that cross section to be. So I'm happy with that one cross section there. And obviously if I need another one, maybe turning it 90 degrees, we'll view it along the y-axis. And again, maybe down at 0, just do the center there. Again, happy with that, confirm. Let's maybe add one more set of measurements. Let's create some calipers, measure some thicknesses, for example. So what we can do is let's measure the thickness of this bottom section here. So again, the tool will remain pretty much the same. It's just the location of the actual tool itself along the toolbar. So I want that to check that thickness. Let's check these two thicknesses. Again, the space bar to interrupt your picking processes remains the same. But again, if you didn't know this, is there is a button now to interrupt it using this little icon on the top right-hand corner. That's been available in older versions. That's just a nice little reminder. And that's pretty much it in terms of what measurements I'd like to perform on this. Before I continue, I'm going to do a couple of quick things. I want to just quickly set up some of my features ready to be probed. Some will be extracted from scan data. I need to set up some tolerances, maybe some GDT measurements. So maybe start with my datum cylinder A. You can still double click on your features to jump into the properties. But if you right click on anything in your tree now, you'll notice we have a slightly different menu compared to previous versions. In a metric that people who have created PolyWorks have now, in their mind, streamlined the list of items in there. So there's less options to trawl through. They're giving you upfront the mainly used tools and options there. But if you can't find what you're looking for because of things have moved around, just a note, there's always the search bar at the top right-hand corner. If you type in any keywords, it should hopefully show you where certain tools are either located, or even click on it and it takes you straight to the tool within there. The other thing to be mindful of with a new ribbon is with certain items selected in your tree, the ribbon changes slightly. You'll notice there's a new ribbon tab that happens to appear called Features, because I currently have a feature selected. If I jump in there, this will give me options specifically to any feature type that I've highlighted. if I highlight a comparison point, you notice that featured ribbon disappears, and I now get a comparison point ribbon. So these are, the orange ones are contextual and they're based upon what you have selected. So if there's anything you can't find within the ribbons, there's a good chance you may need to select the item first and then jump into this contextual ribbon to find exactly what you're looking for. So back to our datum A, I'm going to right click and go to properties, so that remains the same. And again, I'm going to tell PolyWorks exactly how I'm going to measure these by, in this case, probing. So I wish to set the measurement method to probe, explain to PolyWorks how I'm going to probe it. These are internal holes, how many points I wish to probe, do I want to best fit, do I want to filter anything out, and so forth. So all that remains the same in 2024 and onwards. It's mainly how you get in there and the ribbons along the top. So let's quickly do the same for our other datum B and datum C as well. So again, tell PolyWorks that I'm going to probe these. Probe 6 points, datum circle. This is the circle on top there. I'm going to just simply tell PolyWorks I'm going to probe. We'll probe a local plane on top. These are internal holes. We'll fix the number of points to say 6 points for the circle, 4 points for the constraining plane. And then in terms of the rest of our features, they'll all be extracted instead. I could go through the properties of those and they remain the same as what you've seen previously. So if I right click on circle 1, jump into the measurement tab, set that to extract. Again, all this remains the same. I'm going to leave them on default. Again, I'd say 70% of the times the default should work fine. But if there's any issues with the extractions, we can always tweak that afterwards anyway. One thing I do want to do now is if I want to now start tweaking with my tolerances or applying GD&T to my measurements, I can jump into my home tab and you can see we have our geometry control button. This opens up the geometry control window, which then allows me to add and remove dimensional controls or even add GD&T controls. So for instance, this cylinder here is quite vital that this is parallel to my datum A. So I'm going to add in GD&T parallelism to datum A. And I'm going to drop the tolerance down to say 0.1. The actual diameter itself needs to be pretty spot on. So again, I'm going to drop that down to say 0.2 plus or minus. These two circles here, I want to make sure that they're good positionally to datums A, B, and C. So I can add position to datums A, B, and C. And obviously, if there's any material modifiers you want to apply to those, you can do so and so forth. And again, tolerance, I'm going to drop down to, say, 0.2 for those as well. The diameter and XY positions, again, all of those I'm going to change at the same time if I wanted to for both circles. So I can highlight both and use a spanner icon, and we'll put in 0.25 for these. Again, all I'm showing you here, all that is the same as the previous versions. None of this has really changed for 2024. It's mainly the ribbon and where some of the tools are located. Let's check if this circle here is concentric with datum D. So circle C, I'm going to add in concentricity with regards to datum D to a nice tolerance there. And getting the rest of those, I'll put in that 0.25 like I did before. The comparison points, taking the tolerance from the CAD model, which are plus or minus 0.5. I'm happy to leave those as they are. The calipers, they default to plus or minus 1 mil tolerance. So again, I'll probably drop those down to 0.5 as well, using the template. So those are all set up, ready to be measured. So I've told PolyWorks what it is that I wish to measure. I've told PolyWorks how I want to measure them. The next step would be to actually go ahead and start measuring. So with the 24 ribbon, we would now have to jump into the device ribbon. Rather than it being laid out on the bottom of the toolbar like it was before, I now need to jump into the device tab, choose which device I wish to connect to. So this is actually split into 3 different groups. You've got your probing device at the top, your scanning device in the middle, and your gauging device at the bottom there. So in terms of probing, you can see here I have a variety of devices. Because this is an offline program, doesn't matter too much what I select. I'm just going to randomly pick an option, maybe the hexagon arm, for example. For the probing device, scanning device, same again, I can pick and choose. Let's keep it the same, so let's have the hexagon arm. But obviously, to connect, I would need the physical devices to be connected to the laptop as well, but because I'm writing this offline, you can see there's a big offline simulation button that I can turn on. With that turned on, I get the same old watermark as you've seen previously. And now I can pretend to connect to my probe. You can see that it will give me the digital readout. So at which point I can then highlight my first set of features. I can then start to probe them. So right click and say probe measured. And because we're connected to a virtual device, it will then run through and pretend to probe these for me based upon the number of points I've specified. So now that they've measured, you can see we have the little ruler icon there to tell me that they have been measured. You can see with a plus box, as they open them up, you can see now there's a nominal child and a measured child. And with that, we can then go ahead and perform our alignment, whether we're doing a data reference frame alignment, a plane line point alignment. Either way, jump into the alignment ribbon tab. You can see there we have our alignment techniques available, kind of laid out across there. To keep it simple, I'm going to perform a data reference frame to specifically A, B, and C, which is exactly what I've just measured. So if I click on data reference frame alignment, because I've already done some GDT measurements to datums A, B, and C, it's already available in that list, and I can hit align, and that has performed an alignment to datums A, B, and C. That's all I wish to probe. The rest I wish to simply just scan and extract. So the next stage will be to go back to our device ribbon tab and go ahead and click on the scanner button. However, there is an alternative to this. If I jump into the measure tab, you can see there's a nice big scan button there to go ahead and just start scanning straight away. The measure ribbon allows you to do other things in here, such as start to extract, start to pick from your scans or manually fit, start probing, set up sequences, and play inspect and so forth. In our case, we can start to scan. We'll generate a new scan, we'll leave the name as is, we'll create a polygon model. Again, because we're offline, we don't actually have access to any of the actual hardware configurations or settings. At the moment, we're just pretending to connect to the device, so I'm going to simply hit start scan and just let it mimic that CAD model. Now, in that case, we've got all the data there. The scans obviously appear on top of the CAD. Everything's aligned. Now that we have scan data, let's go ahead and generate maybe a color map to show us what the deviation is between the two. So if I jump into the home tab, you can see again, we have our measurement tools. We have our color map tool here. All that remains the same as before. So name it if you like, what direction you're measuring, what it is you're comparing against, which CAD model, which data object, and so forth. So I'm going to hit measure. And if I want to edit the color map in any way, you can see there we have the option to edit the color scale. We can turn the color map on and off completely if we want to, and we can quickly dot on some color map point annotations as well. With that, we can then go ahead and start to extract our measurement. So I personally like to simply control everything from my tree. So I can go ahead and highlight all my features that I wish to extract. I could say right click and say extract measured. But like I mentioned, I could also jump into the measurement ribbon and hit the extract button there as well. So I'm going to right click and say extract measured. All those features start measuring. My cross sections, I can right click on the main branch and say extract or measured. Same with my comparison points. And then same with my calibers as well, extract or measured. So all those are now measuring from this virtual scan that we generated. Before we continue, I'm going to disconnect from my arm just to get rid of the digital readout, and the inspection is somewhat complete. The only thing missing from this is a report. So to report things, we now have a review tab. And we can see here we have the ability to view our control viewer. We have the ability to manually take snapshots, create tables, create format to report. But the main method I'm going to show you is using this tool here, which some of you may recognize, is creating the ability to create control views from our 3D scene. It's clever enough to know I'll see what annotations are visible, so it knows what to report in the table format, as well as taking a snapshot at the same time for us. So to do that, I'm going to quickly hide everything out of the way that I don't need. So I'm going to start off by just looking at my CAD model. I'll turn off my color map, and I'll just have my datums to begin with. So if I get this into a nice orientation, move my annotations out of the way, and what I can do is I can create a control view from this 3D scene now, and I'll call these datums, create a snapshot and a table at the same time. So now if I go down to the bottom of my tree view, you can see report 1, double click. I have my snapshot, I have my table reporting that information. If I'm not happy with the table here, there's too much information or columns or fields that I'm not interested in, I can still select it, right click and edit tables like you normally can in the previous version of the PolyWorks. None of that has actually changed within the report editor. Again, the only thing really changed is the ribbons to access or create those items. So I'm going to get rid of my characteristic number that I don't need. I'm going to get rid of this big title. Don't really need to see what units I'm working in or what coordinate system I'm working in. All those are as standard, so leave those as is. And if I needed to, I can quickly create a template out of this, because if I'm going to create more tables and I'm repeating the same process, it's worth creating a template to speed up that process. So next up, I want to look at my next set of measurements, which are going to be my holes. Hide those out of the way. So the idea is I can just move these around, make things look pretty. And then when I'm ready, I can tell PolyWorks to report this into a table format and take a snapshot at the same time. Again, using this, these are my holes. Again, within the report page, you can see there it's taking a snapshot and it's created a table. Again, it's got the extra headers and columns and stuff I don't need in there. So if I select that table now, I could right click and say set using a template, use the simple template that I've created. And then I can drag and drop that into my previous page and see if that will fit in there. But in this case, it's on the slight big side, but we'll make it fit. Next up, we'll do some comparison points. So again, I'll turn all these on that I wish to report in this one instance. Maybe turn on the color map as well. Spread things out. And let's generate another control view using whatever information they can see on screen. So these are going to be my comms 1. Create. And then I'll hide those. So you can see there, right click and hide them from here, which is nice and handy. I can also right click and show as well. So they were available in the previous versions, but they were under a couple of other submenus that you had to kind of go through just to find the ability to hide and restore items. Because it's such a used functionality, they've now made it available upfront when you right click on something. So create a control view, and these will be comms 2. We have caliper measurements. So again, I'll lay these out. And we'll create another control view. These are our thicknesses. And obviously, if there's anything else I need to report as well, say for example, I want to report the look at the cross sections in more detail. So I'll hide the CAD out of the way. I'll have just a cross section visible. Maybe, like I said, I'll add in some point annotations to quickly get some dimensional information, some deviation values. Obviously, this being a virtual scan, it's somewhat close to zero anyway, so it's not as obvious. But if I'm happy with that, I don't have to use the create control views option in the review. I can just still manually take snapshots. If I'm not interested in creating a table to go along with it, I can still just generate a snapshot. Let's hide that one, bring in the side view. Do the same thing. I'll add in some extra annotations just in case. And again, I'll just take a snapshot. So if we go into my report now, you see there we've got snapshots, tables, and then right at the end we have just 2 snapshots. And say, for example, that's it. That's all we want. The parts are being manufactured now, so obviously when they're ready to be measured, I can upload this onto Data Loop. So that means any of the engineers downstairs in the shop floor can then obviously just retrieve the template for this part, and then they can connect to a real device and then start scanning and probing whatever they need. So in order for me to do that, I'm going to, let's just quickly hide and bring everything back. I'm going to save this, and this is our steering knuckle inspection. Okay, and then obviously I can fill in the report information in more detail as well. So I can put in a proper header, footer, even the front page here, for example. I should probably clear everything out and have just an image of the CAD on its own, maybe. Same with the information at the bottom there with, I can fill in proper email addresses, part number, part name, part drawing numbers, and so forth. Again, to access all that information, it's kind of tucked away under this little icon here. This is our piece properties. So if I jump in there, I can start to fill in my email address, support@3dscanners.co.uk. What device did I use? I use a measurement, an ARM-based scanner. Do I have a part number or order number, operator name? So operator name was myself. In terms of the actual project properties, so stuff like the part name and so forth, I need to change my show list to project. And then you can see there I can fill in the organization, customer name, part number, part name, part drawing number. So steering knuckle is the part name. I don't actually have a part number, but if I did, again, I can fill those in. So this is actually outside the realms of the ribbon. The ribbon, as you can see here, have all these little tabs which will change as you flick through. At the top here, these are your kind of quick access tools. So piece properties being one of them, as well as switching between pieces is another. Your undo, redo buttons, obviously you always want access to those, so they're a part of what we call the quick access tools, as well as the ability to quickly save and upload to Data Loop. So that's what I'm going to do here. Save this. And then I'm going to upload this to Data Loop. So here I'm uploading the entire workspace with this project and with this one piece that I've measured. I can type in some information so I can let the operators know, any extra bits of information, how it should be held, what settings they should be scanning at maybe. But again, all that can be, it is down to you to fill that in. Upload. And you can see there, I can make sure that I'm uploading to certain areas of the database or with certain restrictions. In this case, there are security policies that can apply. So only people with that access can then access this workspace. So if you're dealing with multiple suppliers, maybe this is only relevant to one of your suppliers and you don't want the other suppliers to be able to see it. You can apply it to a security policy that only that one supplier has access to, or it could be a different department. So you've got a wood shop, metal shop, and so forth. You can even set up some data retention policies. Upfront, you'll keep all the data, but if whoever's in charge of the actual data loop management can set things like deleting out scan data after a period of time, say 90 days, or even deleting out whole pieces after a number of days, or even after a number of pieces. Deleting out the raw scan will keep the results, but lighten the database. Or deleting out pieces will actually remove that information because you just don't need the information regarding the old pieces anymore. So with that now uploaded, if I were to open up a web browser, jump into my AWS data loop, and I was to search for this steering knuckle, I'll be able to find that project available on the web interface. So here now, now that's uploaded to data loop, other operators who are connected to data loop can potentially find this inspecting program, download it on their version of PolyWorks to then start inspecting. And as they upload the results, I could be here managing or viewing the results being uploaded to the web interface. If I even jump into that project itself, you can see in here, I have access to the results of, obviously in this case, just the first piece, but I could be jumping between the different pieces. I could be seeing exactly who is measuring each piece, when it was measured, any fails. I could be monitoring and setting up alerts to say if anything is out of tolerance. Ping me an alert to say, a certain dimension is out of tolerance. We can even have discussions and so forth. So there's a lot we can do with the data loop side of things in terms of analyzing, as well as communicating and collaborating with engineers and different departments and so forth. So thank you for joining us for this video. Hopefully that gives you a quick overview of the new interface of the PolyWorks 2024 ribbon and a refresh on how we can create a basic inspection workflow.